So we use logarithms because they are very helpful in terms of being able to manipulate some equations. There's a few properties of logarithms that we have to go over that are going to be fairly useful for us when we start to do just that. So the first one is if you multiply any number and you take the logarithm of it, that's the same as adding the two logarithms together. So log of x times y is the same as log of x plus log of y. Now it's reversed with division. How about log of x over y? Instead of addition, you just do subtraction. That's the log of x minus log of y. Now one thing you might notice, I didn't put any bases in there, like log base of x. That's just because this is general for any base, so it's easier not to add another complicated thing in there, so I just write them just as plain log. All right, now the last, but most definitely not least, this is probably the most useful one. If I have log of x to the power of r, that allows me to bring this r out front. So again, just to reiterate, this r used to be up there, but I can bring it out front, so now I no longer have an exponent. That right there is really the cornerstone of what's going to allow us to be able to solve for x when it's an exponent, is that the logarithms allow us to take that exponent and move it to the front. So let's look at what this looks like. Let's see, let's say we want to expand something. How about expand the log of x squared square root of y over z cubed. Now this looks worse than it is, don't worry. So the first thing that we're going to want to do is if there's anything in there that's multiplied together, we are going to want to add it. If there's anything that is divided, we're going to want to subtract it. So let me show you what I mean. So here we have log of x squared times the square root of y. Well, instead of timesing them or multiplying them, let's just add them together. And then finally for z cubed, well, that one's in the denominator, so we're going to have to subtract it. All right, so far so good. Now let's get rid of those exponents though. So that third rule that we went over said I can take whatever the exponent is and move it out to the front. So this is going to give me 2 times the log of x. Now remember, what is anything to the square root of x? The square root of x is just, in this case, y to the power of 1/2. So I'm going to have 1/2 log y minus 3 log of z. Now when you're expanding these, you know you're done when you have x, y, and z all by themselves. So there's nothing around them. So here I've got my x, my y, and my z. There's no powers or anything like that. So I can go ahead and sort of pat myself on the back and say, job well done. So the opposite of expanding, if you want to make them bigger, is to contract them. Let's take a look at one of those. A little more space. So if I say contract, how about 1/3 log of x plus 3 log y minus 2 log z. Well, let's deal with these. Let's put things in exponents first. Let's take whatever's out front and make it an exponent. So this is going to give me log of, now x to the 1/3 is the same as the cubed root of x plus log of y cubed minus log of z squared. So all I did is I took what's out in front and I put it back up in as an exponent. Now I go backwards again with those other two rules. If I add them, that's the same as multiplication. If I divide something, or if I subtract something, that's the same as division. So I'm going to have the log of cubed root of x. Now I'm adding the log of y cubed, so I'm going to multiply them. Then I subtract a z squared, which means it goes down there. So that's all we're doing. We're going to be going backwards and forwards, expanding and contracting these functions for logarithms. We're going to be able to, or we're going to learn how to be able to manipulate them and what equal expressions are going to be.